cover the first part of chapter 4, and then Soonjo will cover the later part of the chapter 4, and Mohammed will lead us for the discussion session. And on Wednesday we will have a midterm exam. As I told you that through email, the format will be similar to 2014. But one exception is TA will provide one exam problem around the software. He has a lecture on this. And there are small changes on this schedule, so that the invited lecture by Professor Byung-Chul Kim is set up today, but he wants to move down to 9th of November, this Wednesday. So I moved forward these two classes, one sessions forward, right? The assignment is same, but the schedule is moved up because the invited lecture was previously in 2nd of November. It's down to 9th, so that the other tools are moving up. So Yubin, Ungsig are affected, right? Question?
What software?
He has a lecture on software.
Oh,
Transcad and other things, right? So about your term project, you prepare. I don't know. He preparing his problem. All right. Any other question?
To the become then include the student lecture.
Yes. Yes. Coverage is yes. Yeah. But I prepared the exam problems, right? So you can expect that mostly based on my part, right? So, but student lecture is also coming from my previous lectures. Other questions? No. Then we go on to slide set for today. So building blocks of step.
시간도 똑같죠 지금. 수요일 날 이 시간.
Yes, and TA will have a travel with me, so Younggi, right? Inan will guide you as a TA, temporary TA for the exam. All right, chapter 4 is building blocks of step, and sections are challenges for step and components of step standard. Those two sections I will cover, and then Soonjo will guide you around step methodology and architectural issues. So what is the challenge for step? We are talking about computer interpretable representation and exchange of product data. It is about IT standard, right? So something like XML, Express languages. So the step standard is representing standard itself as a computer interpretable, parsable, using computer language. Right? So computer can process the step model. And it is about neutral mechanism. Neutral means it is independent from any commercial software. So neutral means neutral from commercialism. And suitable for neutral file exchange, but also as a sharing product database and archiving. So exchange of file was the baseline. It was starting point. But after that, they start to use database. And then database is accessed by the software directly through some kind of API or interface algorithm. And archiving is long-term data preserving, archiving for more than 50 years. So those are requirements. This is just a baseline explanation between exchange. Right? So design, analysis, and manufacturing or machining, and between design systems. We usually talking about these two exchanges, design, CAD systems. But you should also think about other ICT systems. Right? As you see from smart factory or industry 4.0, more and more things are connected. Right? Connected. IoT means everything can be connected through internet. So the range, the scope of exchange is increasing every day. Not only CAE or CAM, there are more ERP system, MES system, or SCM, supply chain management, and logistics, robots, including robots too. Right? So how can we exchange design? But the information is generated from design mode. And CNC also is, you can think about robot is a kind of CNC machine. So challenges are increasing, requirements are increasing. So objective for step in the beginning, and as you expect, the objective is increasing every day because of the connectedness of all the machining or manufacturing or industrial objects. The scope of step includes all product data for any stage. Any stage. Stage means the timeline of the product life cycle for any industry. Any industry means the scope of industry is increasing. Automotive, shipbuilding, building construction, chemical plant, medical, pharmaceutical is increasing. Right? So scope is increasing. And STEP should support the complete and unambiguous archiving or exchange of product data. Also sharing of product data. And compatibility. There is two different compatibility. Upward compatibility and downward compatibility. It is always required by any standard. Say, there is a new software. You can expect, say, Windows 10 or Windows 12. What is the current version of Windows? 9? 10, right. So there, can you open something which is prepared by Windows 5? There is downward compatibility. Or if you jump up into the new Windows system version, say 13 in the future, can you do something preserved files and operations is working in new OS system? Similar to say CATIA, right? New version of CATIA. Sometimes they cannot handle old version files. Right? So we are talking about upward compatibility means new versions, and downward compatibility is old versions. Should be saved. Right? And also the standard itself can be updated. Standard itself should be extensible in the future because Industry 4.0, IoT, the requirement scope is increasing. So you need to upgrade step. Compatibility with other standards from IEC and other organizations. Implementation also required. Software implementation and testable. Implementation should be testable. And this is another example of process and use case of step. This is a domain. Domain means industrial domain, aerospace, automotive, electronics, this domain, and then information models. This is APs. So based on each domain, new application protocol has been prepared. So CAD, mechanical 3D geometry, and product manufacturing information and assembly is standardized through the AP242. This is a new one. And based on this one is 203 and 214. 214 is not appearing here. And product management data, PDM or PLM is 239. And composite manufacturing is 242 and 220. And electrical harness is also there. And system engineering and analysis. So it's a domain-specific APs are there, and they should talk each other. And what is data sharing, data archiving, or exchange? So product data exchange is, you can think about the file exchange. File exchange over any file, Word document, or XML document, HTML file. But there is so that file exchange means there's a multiple copy of the same files. Right? Because I'm sending a file, then my file is sent through the email. Right? So receiver has the same copy. So there is two copies of the same file. Sometimes it creates problems because my file can be modified or his received file can be modified. Then there is a mismatch. If something is a part of the car manufacturing, so that the design part or design drawing is modified by component manufacturer or myself, and then final assembly may create problems if versions are different. So that sharing can be it's better, right? Sharing, because there can be a single copy, right? Single copy. You can think about your bank account. Printed bank account can be misleading sometimes. Right? So online access of single copy, the master copy, can be better. So single copy can be shared. This is more advanced way. And the other one is archiving. Archiving is preserving or storing the design model for a long time. Say nuclear power plant needs more than 50 years of preserving or storage of design data or product model. Say in Korea, the first nuclear plant is decided to disassembly, but they need design data to analyze whether it is safe enough to assemble this part or this portion. So, but 50 years ago, there should be no CAD system. Okay? Only paper drawings are available there. So how can you make a FEM model out of paper drawings? And is that paper drawing is same as the current operational power plant, or there are some modifications there? So it's not simple problem. So configuration management is a way to handle this kind of things. Configuration and management. Or this can be said is a change management, the same as change management, design change management. Okay? Through the long life cycle of operation of devices, configuration management or design change management. And this is a project inside the STEP community about long-term data archiving. Right. So they're trying to preserve data designed and product produced in 2012, but they want to use in 40 years later for some reason, for safety analysis or disassembly, or say modification of the plant. Modification of what? Is airplane, something? Right? So archiving, because the software or hardware or operating system of that machine can be different. Right? Probably different. The chance of difference is higher. Right? So in this slide we are talking about independence. Context means domain or industry. Domain independent specification. Building blocks of the standard. So common resource means SMRL. I talked about this one the other day. SMRL, step module repository library, right? Module repository library, SMRL, and they include most of step parts, and among them is common resource. Common resource means express constructor that can be shared by other APs. So we call it common resource. The other one is dependent portion. So application protocol and other things, there is a domain or context dependent. Here, once again, the step on page, I'm saying that this part, the downside, lower part portion of step models are common resources. That is context independent portion, I hope, but not all of them. Some of them are context dependent on this part, but it is a little bit in between perfect independence or perfect dependence. So there is a gray area somewhere, but the overall part, the application protocol, AP 200 series are all domain specific or industry specific part of that. This portion shows application modules, many modules. You can see that 1,000 numbers, but these ones are same as previous parts, but they divide into modules, common resource modules, that they are stored inside resource library of step modules. And this is a little bit outdated figure, so that there are more than this in current version of SMRL. So you see that there are many. I told you that 600 modules inside library. And data definition from the exchange format is separated out. Data definition, so product model. Product model of car, product model of airplane, product model of ship is defined by information modeling language Express, or you can think about UML. At the time, they are saying specification or schema. This is the information model, and that is defined by Express language. And then implementation or exchange. The real model is defined by physical model or database access interface. So because they are separate, these two layers, they can be modified without requiring change to the other parts. So implementation and representation is separated out. So physical file is for exchange, and also SDAI, that is a database access interface, and the other part, the specification or schema itself, is defined by Express language. All right. Question? And then conformance classes or implementation, validation, because software should be used and standard also be validated, because as you are talking about the length or weight, it should be validated by a person, the other independent organization. So in step, we have a 300 series and 30 series for methodology for conformance testing and real data set. This 300 is a real data set corresponding to the AP 200 series. So each AP has their corresponding 300 abstract data set. Test data set is assigned for each one. And section 2, once again we are talking about components or subdivision of ISO. There's a description method, implementation method, conformance testing, and data specification. This is express language. And then there is integrated resources, application protocols, and interpreted construct. So step on a page is grouped into these. The same model is divided into groups or blocks, so that you see that this is a 200 series of application protocols block here, and 10 series of express language and description method, and 30 is for conformance testing, and also 300 ATS. ATS is corresponding to APs. And then it comes with AICs and AIR or GIR, integrated resources. And then they becomes into the common resources in the current situation. So this is a little bit old models, old names. And implementation method for physical file and also data access. Data access means direct access to the database. Instead of physical file, the file exchange. This is for file exchange. Question. And description method, that is express language. So in invited lecture by Professor Kim Byung-chul in 9th of November, he will explain more about XML and express. So this is description method. So information modeling and UML. UML is also kind of XML. XML, UML, Express. They are competing each other. Information modeling language. Common mechanism for specifying data construct. Construct means programming. Formal language developed by the ISO community. First time, and that was express language. But now the express language is very good language, but it is not so popular. So only small number of people is using express. So they are trying to change to more popular language such as XML or UML. Also, existing languages at that time, at the beginning of standard community. At the time, there is an evaluation for use for that purpose inside STEP community, but they are not satisfied with that existing at that time, 30 years ago. They are not satisfied with that existing language at that time, so that they produce their own language. Implementation method, see that there is a physical file exchange. Okay. Part 21, and there is also a data access interface to the database. Two kinds. Right? File exchange or sharing of data access interface. So they separate out express language, the modeling, information modeling, and the implementation itself. So two layers. But it's the same again. Because of this separation, it's easier to have a compatibility, downward or upward compatibility. conformance testing. There are 2 series, as already told you that 30 series is for methodology of conformance testing, and 300 series is test cases, test data, real data. Real data means for the automotive industry. AP214 is for automotive industry, and then there is a test model for cars, Sonata, Avante, for example, or Benz model, S series, the test model for testing for cases. So they have some kind of test data for testing the APs. So they is an industry data, real data. And then, sorry, right.
How do you test an AP exactly? How does it work?
Right. So it is something like you or government has a stamp on it. So somebody, Katia, Dassault system announced that we develop and trying to sell the AP203 standard translator. Then somebody should test whether the software is working well, and then they stamp on it. Oh, it's ISO standards compatible.
Translator from what to what exactly?
If it is for AP203, then AP203 files. 214 is for car models. 218 for shipbuilding models. Right? So translator for the industry. Right? And then Dassault or UG, Siemens is announced their translator sales, right? But somebody should say that this is okay or not, right? And then some organization, usually coming from government, has a test of software using that test cases coming from this. There are several of them. Right? If they use this test okay, it is compatible to ISO standard, then you can sell.
But to translate the model, you need the model to be compatible with the AP, right?
Sure. That's why the test data is prepared by AP developers. Questions? So, once again, the data specification is divided into blocks. And here another model is a similar one. Here they are more talking about APs. But AP is divided into ARM and AIM. Right? And supporting this AP, there is AICs, there is 500, and AIM. This is domain dependent part, slightly dependent. And then common resources. There is application resources or generic resources. These portion we expect is domain independent or industry independent models. This part is in between. It's in between. So it's a gray area, independence and dependence. Okay, so IR is independent. And integrated resources, there are many of them. Small portions, say mathematical, geometrical, and material. So it's baseline theories you can expect. If you want to design a car, you need to know about gasoline engine and shock absorber and driving and tire pressure and then sliding wet surface. There are many, right? So these basic elements used for description of any product. Any product means domain independent and not intended for direct implementation. This is very theoretical baseline component, common to any industry. Reusable component intended to be combined and refined. Refined means that generic parts, common part or basic part should be defined for specific use to meet specific need of industry. So there are two series based on generic, very baseline, and also a little bit higher level application resource. So integrated generic resources, 40 series is a very basic baseline. Generic means any application. Right? Visual, some example is 46 for visual representation. And one of them, FIGS is another ISO standard, or JTC1 computer graphics standard is for 3D, and previous to them is GKS. It is 2D graphics kernel system for JTC1. JTC1 is for joint standard between ISO, IC, JTC1, Joint Technical Committee Working Group. 24 is for computer graphics. And they make a standard about computer graphics, and FIGS and GKS was there. Right, so integrated resources is generic. 40 is fundamental product description of shape and geometric models, and then also 100 series for finite elemental analysis and drafting. Drafting means a drawing, 2D drawings. That is a baseline structure at the time of development. And 100 series for application resources, integrated application resources. There is a particular application context, means say this one, finite element analysis. Is it generic or application dependent? Probably in between, right? In between. Finite element analysis. Right? This is not popular in, say, chemical or biological world, but it's popular in mechanical, constructional, aerospace, or building construction, nuclear, right? And drawing too, right? So this is in gray area, so that it is domain coverage is wider, but not all of them. Right? Mathematics is so very basic, right? But this one is in between, right? In between. So we call this is application context, particular application context. Reusable information consists of foundation of step. So once again, the 100 series is integrated application resources there, and 40 series and 50 series is here, right? And application modules 1000. Now return back to application protocols. We covered in chapter 7 already. So you already know about what is application protocol. So application should be implementable. That is real use in industry. AP. Include express information, specific product data need for industry, and also domain specific terminology is used. As you expected, shipbuilding is very special in terminology because shipbuilding is a long history of 1,000 years. Comparing to the automotive is only 100 years of history. Right? Aerospace, only 100 years. Right? But shipbuilding, 1,000 years of history. So that terminology is very historical and unique. So I'm saying that domain-specific terminology is used for that domain. It is used in application protocol. Conformance class is for testing. So that we come back again, the activity model, reference model, and interpretation. So mapping table, right? Mapping table is missing somewhere here between ARM, AIM, right? There's a mapping table. And then conformance classes. These are components of AP. And interpreted model of 500 series Now they changed to the modules now. Anyway, this is when they develop application protocol, they found that there are common parts between industries. Say common parts between automotive, shipbuilding, and aerospace. How can you say there are 3 different APs, but they share similar construct. So they separate out those parts as AICs. Now is application. So the concept of modularization coming from this AIC. All right. Now return back to that's the trend of step architecture into AP and AIC was up to 15 years ago. Nowadays we are moving on to modular architecture. Current situation is modular APs, and modular APs has this kind of structure. This is the old structure of 5 components, but now is modules, and modules are gathered into 6. That's it for question. Then Soonjo will cover the. Oh, thank you.
Application protocol is packet 200 to 299. When Prof said how can find 100
There should be a need from the industry. Otherwise, nobody will develop such a new protocol, right? There should be a need. Say, somebody say, robotics world, or say, bio something, new industry. They need some kind of their own application protocol. So please, you are expert in steps, so please make a new application protocol for our industry. And then somebody will start the discussion. How? By gathering requirements coming from the industry.
질문은 만약 200번째 꽉 차면
The numbering system. They may find another way. You can do it. But they expect 100 is enough for industry numbers. I guess. So numbering system is increased, so they use thousands numbers. More than 10,000. No worry, this is just a number. ID. Any other question? Okay, then Soonjo will cover.
Okay, I'm TA Soonjo Kwon, and today I'm gonna explain you about step methodology from chapter 4.3 to 4.5, I guess. And I made this presentation file based on Professor Han's material, and also I added some couple of slides that I'm given from another person. So 4.3 is step methodology and some issues and conclusion. I'm not an expert on this area, so correct me if I'm wrong, Professor. And if you have any question, please ask me, and Professor will answer you. And there is a resource, there is an effort that integrates some resources and application interpretation. I will explain it more detail later. And you saw this slide already, and it is more modularized. It will be in the future. And I want you to understand in this context is there is layers in step itself, and some layers are context independent, some layers are context dependent. Context dependent are APs, for example, shipbuilding or automotives, something like that, that is context dependent. And there are generic resources. We call it integrated IR, integrated resources. So Express is the language that explains and contains the basic models in STEP. And ARM, application reference model, captures the information requirement. So if I want to make a AP in shipbuilding industry, then I need to make a AAM and also ARM and AIM, something like that. But you have to understand the ARM, it contains the requirements in the specific industry or context or domain. So ARM can be represented as a graphical model language, for example, IDF1X or Express-G. And AIM, it itself is an express schema. If you see the AIM of some one AIM, then it is just schema written in express language. And it can be a baseline concept. And also, we call application interpretation process. If you have an ARM, and the process that you find the right proper and adequate AIC or AIM in the STEP database, that process we call it interpretation. As I explained, ARM can be represented as this or this. Both are just modeling language. Graphically, you can represent ARM. And I said interpretation is a process that you find appropriate model from the STEP database, which is generic as opposed to the ARM. AIM consists of three things. First thing is short form and long form and Express-G diagram. So I explained what Express-G diagram is. And long form is, as it says, it is very long form schema, contains everything. If you want to make an AP, then you will refer to many models which is existing. But you can just say, I will refer to this schema. You can just say this reference, but you can also contain all the referring information in your schema. So if you contain all the things, it is a long form. If you just reference it, explicitly reference it, then it is short form. So I will show you an example of long form schema of AP203. This is a AP203 long form schema. It is written in Express language, and if the total line of this long form schema is around, it's not shown here, but I found that it is more than 15,000 lines. 15,000 lines. Short form may be shorter than this, but it's very long form, so they call it long form schema. This is Express, and Professor already showed this one. Frameworks and architecture are modularized, and this is a similar but a little bit different diagram. I want to say that one AP contains these things, right? But if you go up this way, it is more domain specific, and these things are more generic things. So as you go up, the word they are using is more domain-specific word. But if you go down, the word itself will be very generic, and yeah. And also a different thing from the previous page is it says MIM. MIM is very similar with AIM. AIM. M means module, so a little bit smaller things than AIM is MIM. So you can understand in that way. So every application modules can reference one another, and AP has also reference of AM, and AM itself also reference AR or GR. So you should understand the layer and layering architecture of step inside step. Why they are doing this? I'm also questioning to myself why they are doing this. This modularization, or why? Yeah, you can say anything.
I think it's because it becomes easier to translate to AIM.
Mm-hmm.
So, like as the professor said, the hardest part is translating from the technical terminology to the general resources or integrated resources. So if I can use maybe general terminology or some specific terminology from other fields, which have already been translated before.
Yeah.
So I can just use them, and then the computer can know that, okay, this relates to this specific integrated resource. So
Yeah,
it
right.
becomes easier to translate to the standard, I think.
I agree with you, and I think that's the key point, I think. Yeah, as you said, it is interpreted to the very generic level word and schemas, which is already existed in DB. And by doing that, different domains data can be exchanged very easily, and they can share the common database. But I think the other reason would be, by doing this, you just cannot populate the redundant schemas or data model. Because if you want to develop an AP, you need to find something similar and something you're interested in the step DB. And if it is already there, then you should use it, not make it, and not create a new one. So all they are doing in the step and SC4 meeting is they're finding which one is already there and which one should I create. That's the thing. So the result is, as I show you, AP 203 long form. It's just information model, and this should be. It is very. It should be harmonized with the step database, and also the references between constructs are controlled to ensure consistency between construct and between APs. So these are some examples of step data architecture. It's just capability of step, product information and lifecycle definition and properties representation. And the examples are like this. And also properties consist of shape, material, surface finish, something like that. And representation, you can represent it parametrically or descriptive. And also image, and important thing is geometry. You can make it wireframe model and surface or solid. So as I said, this process, interpretation process, will make an AIM. And by doing that, you will find out which one is already there, which one I should create. So that is the process. But it is done by human, as I said. If you go to the STEM meeting, it is all done by human. So there might be some mistakes. So interpretation is you change all the requirements into the data model. As I said, requirement is in the ARM. So say you want to make a smart factory AP here, then from all the process, throughout the whole process, we will find the required resources here, which is done by human. It can be said mapping or interpretation. This is another slide that I was given by some member in SC4 cabin in France. From this AP, we will find this step resource. This is exactly the same as this, but the scope is the input. Scope will be different. The language they are using is different. And this is another slide that I was given. And you will find all the relationship and resources in the step DB. And it is aggregated and referenced. And in the end, you can create a new AP here. So also consistency is very important throughout the process and between APs. And if you are making these APs, two APs, then there should be common resources here. It will appear. This is another picture and a little bit more explicit. This is schema in Express. This is schema from Express. But as you can see, these two schemas are using schema B, which is existed in AIC. So they're using the same schema, referencing them. So I've explained the efforts, and they are put in how to make a layer and spec in the step itself. And there are several issues in step. Of course, step is standard for the interoperability. So interoperability between applications and domains are always issues. And also, if you develop a standard, nobody uses it, then it is very. If nobody uses it, then it is very difficult. So, in terms of making a standard, you need to cooperate with developers. So you need to provide some good resources and good tools for the developers, and you need to closely cooperate with developers, and also standard organization. And also, if they have very redundant data, they should remove one or remain one. You need to integrating all the data in a consistent way. And also, as Professor said, Express is very good language, but XML is more popular language, so they need to provide better and more good way to implement it. And also, if they provide the XML capability, then they have to make sure that their XML capability is compatible with the existing Express capability. And also, a lot of standards are developed nowadays, so they're very complex. If you see the database in the C4 is very complex. And also, if you want to change something in an AP, then it will be very complex. So change management should be done very good, in a very good way. And So these are the issues, and STEP itself starts from the 1994, and they are doing this more than 2 decades, and their effort to they put a lot of effort to make it very good in a better way, and also they have learned some lessons from the effort, and also they took some prize, as it shows. So this is what I prepared today. So thank you. If you have any questions. So in summary, I want you to know is just layered architecture and what is domain specific, what is generic, and the STEP itself contains those things, and together make a STEP very interoperable and stable. Thank you.
This is discussion session. I am debater. The first question is, there are a lot of international standard organizations such as ISO, IEC, ITU, and so on. Some standards of the same thing can be overlapped by different organizations. From this point of view, how about integrating organizations? Who is agree? Who want to agree?
You mean you need, in the organization level, you need to integrating all the organization? Yeah. If I agree?
Agree or disagree?
What do you mean some standards can be overlapped by different organizations?
For example, I don't know very well, but PLM standard can, if it is ISO organization make standard and IC make standards about PLM, but they can be overlapped, and it is not.
Right. Well, the smart factory standard, ISO and IEC is compete each other. So that one example is the CDD. CDD is a common data dictionary. It is from IEC. Originally it is coming from ISO. Similarly, there are PLMs also, and other things are some not exactly duplicating, but competing standards.
I choose Wang Min and TA agree, and Mohammed, you can disagree.
I disagree because there should be several organizations so they can compete each other, and they have their own idea, and because of their own idea we can choose what is good or not, and if not, the one organization they suggest just one opinion, so it's not good to be well.
You mean competition is good?
Yeah, competition is good.
Yeah, I agree with you. Competition is always make things better. not always, but if you think of ISO and IEC, it's very high level, so you cannot say you can integrate those two organizations. But if you think of some working group level, then if there are two different separate working groups that is doing exactly the same things, then it is very waste of time. And you should integrate those two working groups and you can make a new joint working group, right? So that if you think the hierarchy and structure of the ISO and IEC, there are very many joint working groups in that level. I cannot say we need to integrate those ISO and IEC together, but we should find out that is very meaningful if we can find the working groups that are doing the same things in the same timeline.
Maybe they're doing the same things but using different approaches. Like their ISO is using ISO references and ISO standards as building blocks, and IEC is using its own standards and like lower level resources as building blocks, so you cannot integrate. You either integrate the whole thing or you don't.
Yeah, that's right. We can take different approaches, but if their goal is the same, then why not integrate them together?
Yeah. In the same organization, and you can use different approaches and methods to realize something.
Right.
Would that be better?
But if it's like two people are trying to write a story, you're using Chinese, I'm using Arabic, there's no way we can work together. Right? We're writing the same story, maybe, but it's using different languages.
Standards should take English and French, so it never happened.
Right.
Like for story, and story, I think it's completely different.
Talk.
Louder.
Okay, so I think story is totally different from the data management. So for data we have the exact number and the exact information. But for story it can like imagine have different like scenarios. So it's totally different. And if we like integrate all of organizations into one organization, so we can use different like approaches to realize, to manage data and to make it become more perfect. So I think it's much better. It's more like plausible.
Do you know what major customers in each organization? Like countries?
Country. I don't know about country, but this is telecommunication. And this is, I think, like electronic device. ISO is, I don't know where.
Oldest one, baseline. And new one is coming from IC, and then more new is IT. As the technology development, electricity and telecommunication.
I think the communication with each other is good, but their integrating the organization is not good because
You're
as you say, their focus, their area is different in detailing. So I think they have their own specialty and know-how. But if they are united, maybe their specialty is superior. Maybe. So, being separated is good for each organization.
Yeah, I agree with you. To keep their specialty is very good point, and they need to keep their specialty during the process. But while integrating those two, say, groups, organizations, you need to put some effort to be able to get their own specialty while integrating those two working together. That's the very that's the effort they must do, but that cannot be the reason that they cannot be together. They can be together while maintaining their own features.
I think the starting time that can be possible, but as times go, the CEO or something both staying in two groups. So maybe the time goes by, they'll be the same character. So opinion was that.
No one have other opinions or talking about?
Actually, I have a point for the opposite. Mention, yeah. So if you assume the debate is finished, I can mention. But I think like having many standards competing kind of defeats the purpose of having a standard in the first place. Because the company needs to have one standard to describe its own work and product. So if you have many standards, now the company still has to choose. So before we had like companies competing, now we have standards competing, and it's just like the same problem that we had before, just differently. Yeah. But so I think from the customer's point of view, or from the industry's point of view, it's better if we have just a single standard for every domain. But from the practical point of view, maybe because experts already started working on ISO and IEC and ITU, so it's hard to kind of get everyone to agree together. And this is kind of commercial, so whatever they make, they can sell for money. So it's like a company making standards now, which can be hard to convince to come together. But yeah, I think the main problem is that it's being considered a product. Standard is a product, so if it's being sold, then it's worth money, and it's hard to tell anyone to kind of give up their competitive advantage. Everyone thinks they can win, so that's the main problem.
Time is finished. I want to hear professor's opinion.
What this one?
Yeah.
It's a tough question to me. Say, think about say United Nations or integrated nation. So many people are saying that we should collaborate. Collaboration instead of integration. But there's also a problem. The joint working group between ISO and IC. See that joint technical committee there, ISO, IC, over there, JTC1. That is the case. Yeah, it's not easy. Tough one for me.
Thank you for your opinion. Thank you.